Friends, my name is Amor Rosengels and you're familiar with me. I have recently joined in Department of Chemistry as assistant professor, and in this semester I'll be handling some topics in Physical Chemistry 3, and we'll be starting with a topic that is Electrochemistry 1, which is a 12-hour topic, and in the coming lectures, we'll be discussing basically what is electrochemistry and some things about the electrochemical concepts in solutions and some theories like Debye-Huckel theory, etc. So in brief, the syllabus, in your syllabus, you have mainly two things to study in this semester regarding electrochemistry. The first thing is the various theories of ions in solutions and various techniques for or various methods of conductance measurements and some things regarding the conductance measurements and all. So under the theories of ions in solutions, we'll be discussing activity, ion solvent interaction. Then we'll be having Debye-Huckel theory and a modified version of this theory, that is Debye-Huckel-Onsager equation and Debye-Huckel-Bejerome model, etc. And we'll be having a discussion on Debye-Huckel limiting law, and then we'll be discussing something about the conductance measurements and various factors that affect the conductance and Wien effect, Debye-Falkenhagen and Wien effect, etc. So it's actually a very interesting topic. It may be a bit difficult when you look into the theories of this electrochemistry, but actually electrochemistry is a very simple and not a very simple, but it's very interesting topic and very relevant topic. And in these sessions, we'll be mainly focusing on these kind of things. So whenever we are discussing or introducing a new topic, the first question that comes to our mind is, what is that topic exactly? So in this case also, I just want you to think, what is electrochemistry? You will be getting some definitions and you should know which is more acceptable definition for me. And when you study electrochemistry, this definition should be something that is more and more approved for you. So a basic definition that can be given is, it is a branch of physical chemistry that studies the relationship between electricity as a measurable and quantitative phenomena and identifiable chemical change. So here you have a relation between electricity and chemical change. And this particular relationship you can measure, quantify, and use to interpret various things. And when you are introduced to a topic and when you're going to study a topic, you should be asking, and you would be wondering in most of the cases, why I'm learning this topic and what is the relevance of this topic. So in fact, electrochemistry is a very wide or very broad field which is having application in many fields. Like in biological system, if you're looking in biological system, you can see the nerve impulses or the functioning of various nervous system, and our body itself will be having something connected to the electrical phenomena or electrical impulses that are occurring in our body. A simple example is the synapses of our nervous system and how this impulses are occurring and all. So this is a simple example showing the relevance of electrochemistry in our biological system. If you're considering another case, that is in industry for various metallurgical process, you can see that electrochemistry is used, or in the generation of fuel cells, which is a very interesting and very widely studied field. There is electrochemistry on, or more precisely, we can say that the importance of electrochemistry is more and more appreciated or more and more understood recent days, as we know that the last year's Nobel Prize was awarded for discovering this particular field, that is lithium-ion batteries. There is electrochemistry in that particular field, and how this particular discovery of lithium-ion batteries actually changed the course of world, and you are actually able to produce rechargeable batteries, and you are able to use the mobile phones and all. And all these things are indirectly connected to the studies in electrochemistry and the various concepts that originated throughout the years in electrochemistry that actually paved the way for the development or discovery of these things. So if you're looking around, you can see various phenomena. And if you observe those phenomena, not just look, if you observe those phenomena, you can understand that there is some sort of scientific process occurring. So if you're looking at corrosion, if you're looking at some other why you are painting a steel or an iron pillar, you can all understand the reason behind this, some kind of scientific phenomena. And in many cases you can find electrochemistry in some link to electrochemistry, and this will be actually an interesting thing for you. So in industry, in biological system, and in food, in many other fields, you can find electrochemistry, application of electrochemistry. So this field is actually very broad field, very interesting field, and if you are really ready to explore, you will be having a very wonderful time studying electrochemistry. The birth of electrochemistry occurred actually 200 years back, that is in 1791. So the person, Luigi Galvani, he was actually performing dissection of frog. So electrochemistry actually born in the interdisciplinary field of biology and electricity. And this person, Luigi Galvani, was actually dissecting a frog, and he accidentally touched the frog using two different metals, and the frog twitched. The dead frog twitched, and this actually led to the discovery or the concept of electrochemistry. So, but actually he first thought that this is some kind of animal current or something. But later, Volta, another scientist, he proposed that if you dip two metals connected by a salty media, you could generate current or electricity. And these were the basic or the beginning steps of electrochemistry. Later, Debye and Huckel proposed various theories by which can be used for explaining the conductivity of ionic solutions, and they describe the properties of this kind of ionically conducting solutions. And we will be discussing their contribution or Debye-Huckel theory during the course of the electrochemistry during this semester itself. And they actually gave different ideas regarding these ionically conducting solutions. And it was later on when Faraday discovered various concepts such as how you can deposit from a solution. So you already know the Faraday's law of electrochemistry, how electrodeposition occurs, and these theories actually were developed or introduced by Faraday only after a long time, that is about 1834 or something. It's only after that Faraday was actually able to say that this kind of process would be occurring like this. Or if you pass electricity, the metal will be deposited at the surface, and the amount of current and amount of material deposited would be proportional. And all these things Faraday discovered or proposed only in 1834, after a long time. And one of the most important, this was also a very important discovery, and after that, in the current scenario, the most important discovery in electrochemistry was done by Tafel. So Tafel actually proposed that If you increase the potential at the electrode-electrolyte interface, you would be able to generate more and more current. So, electric current passing across a metal solution interface could be made to increase exponentially by changing the electric potential of the electrode across the surface of which they are passed. So, this concept actually gave rise to the concept of fuel cells. And Groves was a scientist who actually was able to first do this experimentally, first generate the fuel cell kind of things experimentally. And today, the fuel cells are one of the most interesting field in electrochemistry. Development of fuel cells are one of the most important concepts in electrochemistry because they will be providing a eco-friendly and more efficient method for energy production. So this is something some important scientists that are in the field of electrochemistry. And one more thing, you may be familiar with the glucose sensor that we use day-to-day life for measuring the glucose level in the blood. This is actually a device that uses electrochemical concepts. So the blood sugar level will be monitored using this particular sensor, where on the sensor you will be having a particular kind of enzyme which will generate a hydrogen peroxide. This hydrogen peroxide will be undergoing oxidation on the surface of the electrode, and due to which you will be able to measure the glucose level. So in our day-to-day life, we may or may not be coming across various objects or various things that are generated or various processes that are related to electrochemistry. So all this points towards the importance of electrochemistry and how interesting this field will be for studies. Electrochemistry can be mainly classified into two. That is, the chemistry of ionically conducting solutions that are termed as ionics, and chemistry of electrically charged interfaces that is termed as electronics. So in ionics we will be considering a bulk phenomena, that is how conductance is occurring, how conductance is varying. So conductance kind of things are studied in ionics. And in our syllabus, in this lecture sessions, we will be mainly focusing on ionics, that is conductivity, how conductivity varies, etc. And the second thing is the study of the processes that are occurring in the interface, that is, you have a metal and you have a solution. What happens at the metal solution interface? So some examples are you can have cathode, you can have anode, and what happens at the surface of or the interface of anode and cathode? What happens at this interface? What are the processes occurring at the interface? How interface look like? All this come under electronics. That may be further in your next semester and all. So in this semester we are mainly focusing on ionics. So mainly conductivity and how conductance varies and how ions behave in a solution, etc. Just to remember or refresh some of the important terms in electrochemistry. First thing is anode. Anode is the electrode on which the oxidation occurs. And you have cathode. Cathode will be the electrode on which the reduction occurs. And electrolyte is a substance that produce electrically conducting solution when dissolved in it. So examples are sodium chloride. So when dissolved in water, you will be getting sodium and chlorine ions, which will be conducting electricity. And potassium chloride, etc. Useful examples. And this electrolyte can be weak electrolyte or strong electrolyte. Weak electrolytes will be dissociation. The dissociation of these electrolytes will be very low, and strong electrolytes will be completely dissociated in a particular polar solvent. And dissociation is the process by which each of the ions present in the particular molecule will be split into separate particles. And some other terms that are useful, which are very familiar to you, is resistance, conductance, specific conductance, equivalent conductance, molar conductance. About some of the topics that you are very much familiar and you must have already discussed or in your lower classes. And the first one is the resistance. Resistance is the obstruction to the flow of current. So in conductors as well as in electrolytes, you will be observing resistance. It is expressed in ohms. And the next thing is conductance. Conductance is actually the ease with which the current flows. It is represented using Siemens. And the next term that we usually see in ionics is the specific conductance or conductivity. It is the reciprocal of specific resistance, and it is defined as the conductance of 1 centimeter cube of the solution. And you have equivalent conductance, which is the conductance offered by 1 gram equivalent of a electrolyte. And we have molar conductance, which is the conductance of a solution containing 1 molar of that particular electrolyte. So this is the simple terms that is related to the conductance and conductivity. And I hope I want you to go through these topics and prepare a brief record of what is conductance, what is conductivity, what is resistance in the case of electrolytic solutions. And there will be some problems regarding this, numerical problems regarding this particular topics. And please go through this because I won't be discussing this in detail because this has already been discussed in your lower classes. So today when you have time after the class, you just go and refresh all these concepts like conductivity, resistivity, etc. of that particular electrolytic kind of solutions. And be thorough with it because in the last sessions we'll be having a small discussion on how you can measure the conductance and how it is varied according to various different factors like electricity, light concentration, etc. So when we are talking about ionics, it is actually we are talking the story of an ion. You have an electrolyte in your hand. You are putting the electrolyte into the solution or the polar solvent. It will undergo dissociation and ions will be formed. And you are applying electricity or you are observing that in between two electrodes what is happening to this ion. So in ionics, what you say is that the story of this ion, the ion that is formed, it can be sodium ion or chloride ion or any ion. So you place the electrolyte in the polar solvent, the ions are generated and you are observing these ions. What happens to these ions? This is actually what is studied or what is discussed in ionics or what will be discussed in this particular module. So how this ion is formed, how the surroundings of ion will be looking like. So you have to just imagine yourself in that solution in front of this ion. You can see the electrolyte coming into the solution, ions are formed, and what happens to this ion. How its surroundings are. Are the surroundings containing molecules? There will be water molecules, how they interact, how the other chlorine atoms or chlorine ions interact. All this comprises the surrounding of the ion, and this will be having an effect on the ion. And then what happens to this ion? How this ion will move with that solution in the presence of electric field. How its movement will be when you apply a current. How will the surrounding influence the movement of this ion? And the various processes this ion will be undergoing, or various processes this ion would be facing. This is actually the story of this ion in the solution is actually what will be discussed in this module. The activity. Usually in chemistry, when we describe the solution and all, we just mention the concentration of a particular species. But in the case of electrolytic solutions, uh, this is not actually acceptable, or it is not actually correct when you are using the simple concentration terms. In early days, just the concentration concept was used in electrochemistry. Just like if you are taking sodium chloride, the concentration of sodium chloride was taken as this much smaller and all. But this gave rise to some discrepancies in the results observed, and hence a more reliable or more correct usage was required. And in this particular case, a new term was introduced for explaining or describing the concentration of a particular species. So this is termed as activity. So what is the activity of a particular species that is present in that electrolytic solution? So activity actually is something that is related to, it is not an independent entity, it is related to the presence of other species also. So the activity of ith component AI can be given as gamma ICI, where gamma I is the activity coefficient and Ci is the concentration. So the chemical potential of a species may be given as Ui is equal to mu 0 I plus RT log Xi into gamma X, that is activity coefficient into mole fraction. Or in the terms of concentration also you can express mu I is equal to mu 0 I plus RT ln Ci gamma C, or in terms of the molarity also you can express the chemical potential. So a much more useful term is the activity. So activity is the effective concentration of that particular ion in the solution. It may be different for an ion. If gamma is 1, then activity will be equal to the concentration itself. However, more than the usage of activity, a much more useful term is the mean ion activity. So it is very difficult to determine the activity of a single ion. If you have a positive ion, if you want to determine the activity of a simple positive ion only, it would be difficult. But a more useful term is the mean activity, where you consider the total activity of the positive as well as negative ions. This is obtained. This takes into account both types of ions characteristic of an electrolyte. You have an electrolyte. If it is a sodium chloride, you consider both sodium and chloride. It is mean ionic activity and mean ion activity coefficient. So for activity as well as activity coefficient, you can have the relation A plus or minus raised to B is equal to A raised to B plus A raised to B minus. And for the activity coefficient also you can get a similar kind of expression. So V plus and V minus are the number of cations and anions respectively. This is derived from the formula of the unit electrolyte. So this is a more important and useful term for describing the activity of an ion in solution. So in today's class we just introduced the concept of or the topic electrochemistry. The coming classes will be describing, or the next class will be discussing various ion interactions, ion solvent interactions, Bohr's model, Debye-Hückel theory, and ionic atmosphere. the next class. So please go through the syllabus and get refreshed with the earlier topics that you have already studied under electrochemistry. And there will be some texts available in the library. Go to the library. Now you won't be having access to library. Anyway, good materials will be shared with you. And if you have any doubts, you can just send me a message in the WhatsApp or just post it in the group. Thank you.